Then you'll do smooth.
Okay, Stefan, come and do number 2. Let me do the number 3. So they say the sum of the first n terms of the sequence is given as Sn is. And then the first question says determine the sum of the first 24 terms. So meaning we're looking for S24. Yeah, how do you know what you are looking for Tn? I think this one they say S sum. So you take it directly from here. So I'm going to look for S24, which is going to be equal to 2 to the power of 24 plus 2 minus 4. And then what you get is answer 6, 7, 1,
0, 8.
0,
No.
0, 8, 8, 6, 0. Like this. Okay, we're looking for term number 24. How would you get term number 24? You would say, okay, T n is going to be given by Sn again, minus Sn minus 1. Like this again. And then what is going to be T24 then? T24 is going to be S24 minus S23. Like this again. And then from there onwards, you are going to get S24, which is this one again. So you say which it's 6, 7, 1, 0, 8, 8, 6, 0 minus 2, 23 plus 2 minus 4. Yeah, you put this in a bracket. What you get as the answer?
33, 5, 5, 4.
I need what is the answer?
3, 3.
3, 3,
5, 5, 4.
5, 5,
4.
4, 4,
2, 8.
8, 2. 3, 2.
Yes.
Now, this is a typical examination question. This is what you should expect then. Prove that. They say, we should prove that the n term, which is Tn, not Sn. We should prove that Tn is equaling to this. How do you prove which Tn is equaling to that? How do we get Tn? Remember, we said Tn can be given as Sn
Yes.
minus Sn
Minus 1.
like this.
Yes.
Okay, now what does that mean? It means you are going to go to that formula and say, okay, but I have Sn. I know what is Sn. What is Sn? Sn is given as 2 to the power of n plus 2.
Yes.
And then it says what? Minus 4. Everyone is repeated.
Yes.
What is that? That is Sn. What is it that I don't have? I don't have Sn minus 1. I do have Sn, but I don't have Sn minus 1. Let's go and look for Sn minus 1. So I'm going to tell them which Sn minus 1. This means everywhere you see n, you're not going to put n, but you're going to put what? N minus 1. So you're going to have something like this. It's going to be 2 to the power of, instead of n, let's put it with a different color so that you remember. So we've changed the n here. It's no longer n anymore.
N minus.
It is n minus 1. Yeah? Plus 2. Yeah? And then you still have your minus 4. And then here you can see what they are like terms. Say, what are the like terms? Minus 1 and 2. So this is going to give us what? It's going to give us 2 to the power of n plus 1 minus 4. So I can come and substitute it here now. So this is going to be minus Sn minus 1 is going to be given as 2 to the power of n plus 1 minus 4. Like this again?
Yes.
And then if we move on with this thing, then we're going to have 2 to the power of n plus 2 minus 4. This one multiplied by this one, we get minus 2 to the power of n minus 1, plus 1. And then we get plus 4. You see fine?
Yes.
Okay, what should we do from here? We're going to add like terms. What do we say as our like terms? So you do have minus 4 and plus 4.
Yes.
Then you have 2 to the power of n plus 2 minus 2 to the power of n plus 1. Like this.
Yes.
So is that what we're looking for? That's not. So how to get what we're looking for? Then we say to them, okay, remember in grade 11, we said we can split the base. I can write it as 2 to the power of n multiplied by 2 to the power of 2 minus 2 to the power of n multiplied by 2 to the power of 1. Does that make sense?
Yes.
Okay, I can take out 2 to the power of n as common. If I take out 2 to the power of n as common, then what is going to remain here? If you take this one as common,
2 to the power of 2.
to the power of 2,
2 to the
which is 4, né?
Yes.
Minus 2 to the power of 1, which is going to what? 2. And then we have 2 to the power of n. This one, it's 4 minus 2. In other words, what is 4 minus 2? It's 2. Now, this one, you can take it back again. Bases are the same, okay?
Yes.
If the bases are the same, what can you do? Then it's 2n plus 1, which is what we're looking for.